Okay, so thank you for attending. I feel sort of strange here talking about vendors. I feel similar situation like a few years back at the World Cup. Italy and Germany were playing each other, the soccer World Cup, and my wife, who is German, took me to watch the game at the Goethe Institute. And so obviously it was a bit uncomfortable saying anything positive about the Italian soccer team. And so here we started yesterday saying that vendors have a stranglehold on network operators, and finally open networking is enabling operators to get rid of that stranglehold. That was in the keynote of Nick McEwen. And we have been talking about 2 days about how open networking is enabling us to get rid of vendors. And here I am talking about opportunities that vendors can get from one specific open networking technology, which is P4. And I think this is important, of course, for vendors. But as I will tell you in just a second, I think it's also important for P4 itself. I think traditional switch vendors embracing P4 is going to be advantageous to P4 for its widespread deployment. And finally, I think some of the considerations, some of the changes that vendors will have to implement if they want to take care of P4, I think some of those apply also to the open networking community. So let me go through it, and hopefully you will find that this talk about vendors taking advantage of P4 does somehow what makes sense in the context of this event. So, well, I had this slide of what switch vendors are. I don't think I need to go through them. They offer a complete system from the hardware to the operating system, to the applications that run on it. So why am I focusing on switching system vendors, besides the fact that, as Brian was saying, I've been working for one until very shortly ago? Because I think device users, a large fraction of network device users, are accustomed to the familiar APIs and CLIs that vendors have been offering, to their documentation, to their technical support. And vendors offering turnkey switches based on P4 programmable devices might provide a very good path for the adoption, for a very widespread adoption of P4, and potentially other open technologies. But here I'm focusing on P4 because I think the vast majority of network users are not ready to develop in P4. They don't have the skills, they don't have the resources. Some do, I mean, large network operators, web providers, but many users don't. So being able to use devices that are more familiar provides a less disruptive change, less risk. And this doesn't apply to all of the network device users. So in a way, the fact that vendors start using P4 can be extremely beneficial for P4 to be adopted by a wider community. So what are the opportunities that vendors can get from P4? And some of them are pretty, I think, intuitive and straightforward, and they've been said in several contexts. So I'll skim quickly through them. But one thing that vendors can get from having a P4 programmable ASIC in their systems is that they can accelerate their releases. They can shorten the time between their releases, their regular releases. So the time with which they bring new features, new data plane features to their customers, bug fixes to their customers. So this gives them a chance to be current and to beat competitors, possibly coming out with features faster than competitors, ride the wave of new technologies. Again, yesterday in one of the keynotes, it was said that ASIC production has a cycle of 4 years. So by when we have a new feature in an ASIC, the feature is not new anymore. So P4 enables vendors to ride the wave of new technologies and to keep customers engaged. The other opportunity is to take advantage of scale and optimize resource usage in their chips, because they can create profiles that have a selection of features that either the vendor or ideally even the customer can choose. That's just the minimized set of features that the customer is interested in. And so all of the resources of the chip can be used for that. So this enables devices to achieve higher scale and so address new use cases that weren't possible, that wasn't possible to address with traditional fixed function ASICs, address specific markets and consequently acquire new customers. Or another interesting opportunity that vendors have is to offer unique features that other vendors don't have. They might develop proprietary algorithm. Here I have some examples. For example, an innovative load balancing algorithm, or algorithms that support big data or machine learning workloads within the network. Or, for example, this is another example, an algorithm to deduplicate packets inside a data broker network. So these are proprietary solutions that vendors can have, they can implement in their systems thanks to the fact that they are programmable. Or maybe solutions that are not as fancy, maybe they are not proprietary, but they are solutions that are not available in any ASIC. Like there is a need from many different markets for multicast to unicast translation. There's basically no ASIC today supporting multicast to unicast translation. Extremely easy to implement with P4. So this is an opportunity that vendor can leverage if they have a switch system based on a programmable ASIC. So this can give them a unique advantage against their competitors, over their competitors. They can improve their sales, attract new customers, and enter new markets. And finally, I think a major opportunity that vendors have is to be able to finally listen to their customers. When customers want new features, they can tell them, I'm going to give you your feature in a short amount of time, not in 2 or 3 years. And there are plenty of examples. For example, protocols that are there, they are well established, but for whatever reasons we don't have hardware implementations. I listed here some example. MAPT. MAPT is a solution to transport IPv4 packets over an IPv6 backbone, which is very interesting to many large operators today because it allows them to deploy an IPv6 network but still support IPv4. There are no hardware implementations in network devices. SRv6, it's another technology that's been around for a while. There are very few hardware implementations. Beer, a solution to support multicasting, large-scale multicasting, more scalable than traditional solutions based on multicast routing protocols. So all of these are examples of features that customers might want. For whatever reason, vendors did not implement in their ASIC, but customers want them now, not in 2 or 3 years. And programmable switching systems based on programmable ASIC allow vendors to support these kind of solutions, differentiate themselves from competitors, and again, improve sales and attract new customers. And then, last but not least, open their switching system to customers and third parties who can develop their own features, but not necessarily as white boxes, but provide a system that has a number of basic features that are well tested, that are implemented by the vendor, on which the customer can add their own features, just what they need, focusing on the specific use case they want to address without having to worry about developing the basic functionalities, layer 2, layer 3 forwarding, or having to adapt open implementations, which again, for some type of users might be the best solution, but for a large set of users, they don't have the skills to do that. So, this could be proprietary protocols that customers want to have. They could be solutions that are specific of a certain segment. I listed here as an example, an example that has been published by Fox Advanced Technologies of where they want to switch video streams based on the RTP timestamp. So this is something relatively easy to implement, but it's not available in any switch. And it's probably also something that no vendor will want to implement because the market demand is not clear and big enough. Well, an end user or a third party can implement it. And so this, again, a switch vendor that supports that opens their platform to third party or customer development will differentiate itself from competitors and consequently has the opportunity to attract new customers and improve their sales. So these are 5, if I counted correctly, 5 examples of how vendors can benefit from a programmable data plane. And so now what I would like to do is to look at a little bit more in detail at what is the value that this brings to the vendor and to their customers. So, I try to summarize it here in this slide. So, first of all, shorter time to market for new features or new releases of the systems that the vendor is selling. Reduced investment and commitment and cost in developing new features, and that's what enables a vendor to implement unique features, possibly proprietary features developed by the vendors, or customer requested features, okay, even if it's not a huge market interested in that feature, but a set of important customers. Flexible feature support, so being able to have only the features in the system, only the features that are interested for the customer so that the resources can be optimized. And finally, the capability of easily implementing new features, possibly by the customer or by a third party. So all of these 4 items are the values that can be brought by a programmable ASIC. But how big is this value? So, for example, how significant is the reduction of time in releasing a new product, or the reduction of cost and effort and time in implementing a feature requested by a customer? So what I want to do next is to look into that and see and reflect on the fact that this reduction is good, but if a vendor really wants to have a significant reduction, it has to do something. It has to change something in the way it produces its own systems. It has to change something in its process. And then I want to go to these other aspects and see that if a vendor really wants to get a major advantage in supporting flexible features or wants to open their system, they have to make some technical changes to the architecture of their systems and to the tools that they have available for their system. So all of this with the goal to maximize the benefits that the vendor can have. So if we look at the process that a vendor uses to implement their systems and release them, it goes through several stages, and I don't think we need to go through them. I think we all know these. Just want to highlight that the design and fabrication of the ASIC, which is where having a programmable ASIC is going to have an impact, is just one of the steps. And if we look at the overall duration of this process, is 2 to 3 years. Okay, yesterday Nick was saying 4, but finally it doesn't change much. And of these 2 to 3 years, the ASIC design and fabrication takes between 1.5 to 2 years. Not only, but if we look at how often a new ASIC is produced, it's produced every 2 to 3 years. Because one could say, okay, the process takes that long, but once I start working on the software of one ASIC, I could already start producing a new one so that every year I come up with a new ASIC. That's not the way it is done. A new ASIC is produced every 2 to 3 or 4, as Nick was saying yesterday, years. So what happens when we have a programmable ASIC? When we have a programmable ASIC, the stage that was devoted to the design and fabrication of the ASIC is substituted by a P4 development phase, which takes the time down from 1.5 to 2 years to weeks. Maybe weeks is a little bit optimistic, but if you have already a good code base and you just need to implement new features or fix bugs, it's not going to be a very long time. And this is going to take the whole process down to maybe 1.5 years, maybe a little bit less than a year, which is a quite good reduction. But not only, but also the other great advantage that we have here is that we don't have that time discretization anymore, in principle, right? Now, if we want to add a new feature, we don't need to wait for 3 years when we will fabricate, spin a new ASIC. We can add it right away. Yes, but all of this in principle, because in practice, vendors are working with this process. And that's their way of releasing their software. So in order to really take advantage of the fact that we don't need to create a new ASIC, we don't need to wait a couple of years before releasing a new platform, requires to adapt this whole process. So first of all, if we want to do much better, we have to be a little bit, I called it lighthearted with the product management phase, the first phase of that process. Product management in a vendor is very careful as to which features to include in a system. First of all, because the space, the real estate on the ASIC is limited, and secondly, because if they miss one feature or add one feature that was not needed, it's a big damage. Now, with a programmable ASIC, we don't need to think twice or 3 times before in order to decide which features to add. And secondly, we need to make the process a little bit leaner. We need to work with smaller numbers of features. Right now, the process is working with, let's accumulate a bunch of features that we are going to bake in the ASIC, and then we will support it in the rest of the system, in the operating system, in the application, and so on. Now we don't need to think that way. We can think, not saying feature by feature, but almost. We can group smaller number of features, start developing them, then add more. In a way, we have to make, in order to really take advantage of the fact that we have a programmable ASIC, we have to make the process agile or somewhere in that direction. And then also, at this point, it becomes very important to have very modular software. Making the data plane program modular with P4 is relatively simple. I mean, by modular, in this case, I mean where every function is quite independent from the others. But this same modularity and independence has to be there also in the operating system, also in the applications that are up, on top of it. And some of the operating systems that we have in the network devices today do not have this feature. Moreover, we need to be able to heavily rely on testing automation. Because now if we want, instead of developing a large set of features and then test them, we want to be able to develop a feature, test it, release it, develop another feature, test it, release it. We need to have, not to have to spend too much in the quality assurance phase of the process. Now, all of those changes will require time, will require effort. But in the meantime, we can already take immediate advantage of having a P4 programmable ASIC by developing data plane functions and then control them in a way that is independent of the software stack that's on top. So when the vendor wants to add a new function, he's not going to immediately implement it integrated in the operating system with the rest of the system. But it's going to implement it sort of besides the existing functions and control it independently of the operating system. So using basically the same tools that can be used for customer or third-party programming. And in a little while, I'm going to tell you about a tool that we have developed, which is called the pipe, which enables a third party to add features to a Cisco Nexus switch. Now, this same tool can be used by the vendor to, as the vendor is still using the old process, the long and slow process, they can use this tool or similar tool to implement some features quickly and independently of the slow process. Take those features to a level of field trial, offer them to customers so that they can test them, get feedback from the customers, possibly improve them. This also gives more confidence in the market opportunity and in the fact that customers appreciate that feature, and then later on, move on with the full integration of that feature in the operating system and in the rest of the system. So to summarize, for vendors to really take advantage of the programmability of the switch, they need to really make major changes to, in my view, major changes to the process they use to release their systems. This is going to take time and a lot of effort. So in the meantime, they can use the same tools that they make available or can make available to their customers to add features independently of their software stack and their data plane program, but building on top of them. They can use those same tools to develop internally those customer requested features, those unique features, those new protocols that came up and are not widely supported, and have their customers start using them. So this was about the value that we can gain by reducing the time to market and by being able to produce features with a reduced cost and investment. But what about the possibility of optimizing resources and scale? Also there are challenges, because if we want to have different combinations of features, each one of them needs to be supported by the network operating system, which means there has to be some development, some testing. If, again, we use the current process to do this, to create many different sets of features, vendors end up with a huge number of different branches, and that's difficult to handle. Moreover, none of these profiles will be a perfect fit for none of their customers. So the best way to achieve this opportunity, to benefit from this opportunity of having scalable profiles, is to be able to offer some sort of a la carte profile where features are created in a way that's modular, not just in the data plane, also in the operating system and in the applications. And ideally the customer, but even in a first step, even just the vendor can, based on what a certain customer or a certain market segment needs, choose which features to put together. The system is modular, so those features can be put together, being picked and chosen. And then there has to be some level of automated regression testing to make sure that that combination works properly. And this has to be automated because, again, the vendor will need to have many of those different combinations because there will be a customer who is interested in just having very scalable ACLs, another one that wants scalable ACLs, but also wants VXLAN to be supported. So there have to be many different combinations, and they have to be dynamically created. Just a couple of minutes to tell you about the last opportunity, which is the one of opening the system to the customer or to third party for programming it. And there are challenges there because the system, one of the values of getting a system from a vendor is that the system is tested, is working. So we have to make sure that when the customer adds their features, they don't break what works. The customer needs to be able to add their features without needing to see the code of the vendor. The vendor doesn't want to show it, but also the customer doesn't want to see it. It's too complicated. Otherwise, we are back from the beginning. Why buying the system from the vendor? I can take, in fact, open software and just adapt it to my situation. Well, here we want to enable the customer to just add to a basic set of functions that are there, that are reliable. There are obviously issues with availability of resources and issues with the fact that when we add features in the data plane, the control plane, namely the operating system, is going to not to be able to work anymore. So as I mentioned before, we developed a development environment called the PIPE, which is an acronym for Data Plane Incremental Programming Environment, that addresses these challenges. And the way it addresses these challenges, it identifies, we have identified some constraints that we have to enforce on the new code that the customer writes. And the idea is that the environment is going to enforce those constraints. And if those constraints are enforced, we can be sure that the existing features are not going to be broken. The operating system will keep working. So basically, the way this environment works, it allows customers to write their own code. And then there is a set of verifications that are performed to make sure that the new code is compatible with the existing code. And if so, the two are merged together and compiled with the standard compiler and SDE offered by the vendor, which generates a binary for the chip, in our case, the Tofino chip, and the various libraries for the control plane applications. The customer, of course, has also to develop a control plane application which runs on the operating system, independently of the operating system. So the operating system will not know about the existence of these additional features in the data plane implemented by the customer. And the customer will be able to execute their control applications and control just the features that they have added independently of the operating system. And it will not be able, obviously, to control the features in the base code of the vendor. If the customer needs information related to the base functionality, it has to go through the operating system in order to get that information. Okay, so this solution right now is not a product, it is a prototype, but it works and it can be used. And as I mentioned, it can be used by the vendor itself, and it is being used by in this case, by Cisco, to implement features for following specific customer requests or features that they want to implement in an experimental way. With this, I conclude, and if you have any questions.
Questions? Are there any features implemented by vendors that you think would be really difficult to replicate in P4?
Features implemented by vendors that?
Yeah. Is there anything that's in either like vendor ASICs and things like that, and things that are done right now by vendors that would be difficult to replicate in P4?
Yes, there are. There are because of the well-known limitations of P4, like for example, modifying state from the data plane itself. There are some features which is difficult to implement with P4 or inefficient to implement with P4 that are more easily implemented on ASIC, definitely, yeah. Yeah. But, I guess P4 is also evolving in this sense.
One more question?
Do you have any ideas on how to solve the challenge with the limited resources? So
yes, that's a very good point. I skipped those. The pipe solves a bunch of those. All of the other challenges that are here, not the one of the resource availability. If there are no resources, there's no way of fitting a new feature. Obviously, if the new feature exceeds, together with the pre-existing features, exceed the resources, the compiler is going to fail. The compilation is going to fail. That's how you know it. But there's no magic there. If the vendor code, data plane code, used all of the resources of the chip, there's no way to add customer features. So again, there the vendor needs to have some sort of set of profiles that leave enough resources to add something. That's a good point. That's one of the main limitations that we find with programmable ASICs right now.
Let's thank Mario.
Thank you very much.